That's our sponsor.
Yeah, I want to take a moment to thank the folks at Carter Fuel Delivery Systems for sponsoring tonight's event. Of course, that's how we are able to bring it to all of you free of charge. So make sure you say a little thank you to them. Of course, Carter is part of the Federal Mogul family of brands.
And makes a lot of stuff for OEs.
Yeah, big global manufacturer, aftermarket and OE suppliers. So yeah, thanks very much for Carter sponsoring tonight's event.
It all makes it possible for us to give you this for free and later on see it on YouTube and on the Motor Age channel.
Yeah, Auto Pro Workshop will host it there as well. Just a real quick word, you know, gee, because we always hear that all the time. I'm an aftermarket and OE supplier, you know?
Right.
So when you're looking for quality parts, you know, you have to, I know we all stay away from what, I don't know, I call them the white box parts.
White box are dangerous, Pete.
Yeah.
You know, having run shops for years, they've been white boxed out, you can say.
Yeah.
So,
what's that old adage, you get what you pay for, right?
Exactly.
So,
it's better to go with a name brand that you know they're ISO certified and it goes into an OE vehicle.
Yeah. Yeah.
That's the thing to put on a car.
Yeah, and I'll tell you something, I learned a few interesting things at the recent Apex event in Vegas. I didn't know before. Maybe some of you guys might appreciate that information. You know, there's a difference in parts manufacturers.
Oh, big difference.
And the top line guys are all what they call full service manufacturers. So they're not just designing and making, engineering the parts for the vehicles, but they're also very involved in the support and training and so forth behind those parts. I know Carter has quite a bit of training material online, and we'll share that information, you know, a little bit later on.
I have a question.
Oh, question.
James asks, are they made here in the USA?
I don't know if we can say that for everything or not. I'd have to check into that for sure.
You know, I'm not going to speak for Carter, but I know most big manufacturers try to manufacture a lot of stuff here, and sometimes they do get stuff from other countries.
Sure.
It all depends.
Well, you know, I mean, I believe in the Made in USA logo. I really do. So we want to keep the jobs in the United States, but we have to keep in mind too, this is a global economy. You know, these companies are supplying not just the United States, but countries all across the world, you know, and manufacturers all across the world.
And we're just not totally sure of that answer. Maybe if there's someone online with us from Carter, please type that in, and we'll be more than glad to pass that information along.
Or you can go to a great Federal Mobile resource. It's fme360.com.
Oh.
It's a great link there for not just
you
the Carter
remember
brand, but all of their brands that you can get a lot of good information on.
Excellent.
And since we had the question come up, guys, let me just throw that out there. I always tend to forget to bring this up when we do our little webcast. If you do have a question, by all means, use the chat function to type it in there. And we have some great folks from TST behind the scenes working with us tonight to help you with those and to make us aware when you have a question posted so we can address that for you.
Right, and we're more than glad to answer all your questions. Just type them in. We have our Vice President Pierre behind the screen there. So he makes believe he's me typing in, but it's actually Pierre. And we have lovely Doreen on the camera tonight.
On the camera tonight, yeah. So on to the subject at hand, fuel system testing. You know, first we're going to show you some techniques where you can test the entire system, but at the heart of that is the fuel pump, right? And I just happened to, and Carter folks, if you're watching, forgive me, but I kind of butchered one up earlier today to show you. I mean, this is what we're all used to, you know, for our fuel delivery systems, you know, the heart of the fuel system. And we're going to talk about a few things that are impacting this, because, you know, Carter and others have shared this information with us. Most of the pumps that are returns as supposed defectives are just fine. You know, there are other
issues like voltage drops at the connector here.
Sure.
In the back. You know, a wiring harness that may not be good. This here is our pressure sensor that helps with your evap system, but here these connections go into the actual pump. A lot of times I've seen many problems with wiring.
Sure.
And people think, well, it's the pump. Also a big failure, I know, I'm sure they back it up, is the dirt. When you put this in, the dirt that's on top of the tank sometimes slides in, gets picked up through the stock, very fine, starts killing a pump. So a good pump could even go bad.
Sure, sure.
But I think you're right here. Most of them are not defective, but are returned as defective due to something else. Could be a relay problem. Voltage drop, as we've done before, voltage drop is one of the biggest problems out there.
Yeah.
and people don't check for it. So we're going to show you some stuff tonight.
And that's one of the reasons that we're doing, webinars like this and others that we've done in the past and will continue to do, is so that we can look at the underlying causes of why guys are having problems when they do make the decision to pull the trigger on a part and replace the part, only to have the problem resurface, a day later, a week later, a month later. We don't want to see you do the job twice. You certainly don't want to do the job twice. So
No doubt.
we'll take a look at some of the reasons now. Here are some of the reasons that fuel pumps in particular tend to get the blame. One is a very simple one: contaminated fuel.
And Pete, contaminated fuel, another thing is they should be telling their customers with contaminated fuel, do they fill up when there's a gas truck in the station? Now, having run gasoline stations years back, I can tell you I always shut my pumps down because at the time when they were dropping 8,500 gallons of fuel, what's going to happen? We're going to stir everything up that's on the bottom. Any tank, whether it be metal or fiber, you're going to get condensation, and that's why they have electronic water monitors nowadays, or the old days of the stick and the paste to check. But when that gas drops down and you happen to be fueling your car, or the customer in this case, they're going to get all that stuff in, and we're going to get contaminated fuel.
Sure.
Besides people who put diesel or kerosene, over the years, I've seen just about everything.
Absolutely. And of course, the contaminated fuel doesn't necessarily have to be straight from the pump. I mean, I know my boy, he's struggling. He keeps just enough gas in the car to get him where he needs to go.
Fumes.
So you're looking at people who generally keep their cars less than full, and it's a metal tank. And what's going to happen to the part that's not in the gas? It's going to rust.
Oh, well, especially like my son Craig, when you're talking about Las Vegas. When he went out there, he drove to the airport with a hurricane coming, had fumes and came back on fumes because we've had a problem out here in New York, obviously, from Sandy.
Sure.
And he had practically no gas in his car. How many people do that? I think, maybe guys our age, I'm pretty anal, I keep fuel in my car. See it half, I go get more fuel because I use a lot of fuel.
Sure.
Unfortunately.
Sure.
So I think that's an important thing, keeping the pump submerged rather than running it dry. And that's when you start having problems with that pump as well.
Right.
Yeah.
And like you were saying earlier, when you get that contaminated fuel in there, the fuel sock begins to get contaminated, clogged. It's going to get to a point where, I mean, look at this. This is actually submerged in a well.
Yeah.
We got to keep this little well full. So if it can't get past that strainer, then this is going to, I mean, you can run out of gas with a full tank of gas.
And speaking of that, if we were checking amperage on that when we have low fuel, we're going to have low current if we don't push fuel. And when we start doing vapors like years ago, when they had a lot of the gas, they were using different additives in it, and in the winter when it gets warm out, when it's not supposed to get warm, then we have problems with an aeration type of pump. Rather than pushing a liquid, we wind up ruining the pump because we're pushing vapors. Almost like the old vapor lock days of a carburetor.
Sure.
A carburetor.
Sure.
When Carter built a lot of carburetors, actually.
I got a little side note in there. I mean, and the guys who make the fuel pumps, they know that. So, and that's one reason I wanted to cut this apart. I mean, we all seen the strainer on the bottom. We all know about the inline filter on, in the car. But how many filters are really on these pumps? I mean, here's another one inside the well.
Right.
Many cars have, of course, the screen in the injectors themselves, and there's several filters all trying to keep that dirt away from where it shouldn't go.
Exactly.
And the car's benefit, I mean, they do make a special material. It's a non-woven medium to help collect even more dirt and still allow fuel to flow. So.
And the nice thing here, this is the right way to change a pump nowadays. This is a fuel module. Mm-hmm. Too many people when it comes to changing a pump, they butt connect wires in here. They actually just put the metal pump in. There's an issue with that.
Yeah.
And if you're gonna do the job the wrong way, get ready for a return.
Oh, sure.
That's why these guys Carter has a complete unit, so you don't run into a problem. Just don't forget, if it doesn't, and I'm not sure if they do or not, come with a lock ring and a gasket.
Oh yeah. Oh yeah.
Because some of them you purchase don't come with them. So
I guess
diagnosis.
Yeah, well, the boy, that contaminated fuel, I would say too, when you're doing that repair process, then I guess a big part of that, change the fuel filter.
Change the
Same
fuel
thing.
filter. No doubt.
And clean the tank. Make sure you clean the tank.
There's a lot of stuff in the tank. You know, talking about cleaning it, one of the steps is just taking that fuel pump out. A lot of guys will just take the locking ring off, pull the pump up, and now what happened? All that fine dirt, that fine silt is going to go down. And here's something I used for years, you know, the snap-on air vac. Do not, 3 times. Do not use an electric vacuum unless you've got a death wish.
Yeah.
You know, it wouldn't be a good idea to be sucking hydrocarbon fumes in. This is operated, as you can see, by air. We could go around the top and suck up all the dirt and then take the lock ring off, another suck. And I used to leave it on right as I'm pulling it up to get any last pieces of dirt, so nothing to go.
And this is adding more dirt to the problem.
And then if you look in and you see a dirty tank, you must send that tank out to be cleaned, or you could do it yourself by rinsing water, but you got contaminated fuel to get.
Well, you want to make sure you have an approved shop caddy to get that fuel out.
Right.
And in fact, a recommendation from Carter is, if you're going to take the fuel out of that fuel caddy, filter it before you put it back in the car. Or you're just going to take whatever's running in that fuel and put it right back in the tank.
Because it takes a while for it to drop.
Sure.
Yes.
Sure, absolutely. Well, so much like contaminated fuel next to incorrect diagnosis.
Oh, that happens. That happens in our business.
Yeah.
Incorrect diagnosis, Pete is right on the money, does happen quite a bit. And that's usually, Pete, from not knowing the system, not checking something. I mean, you know, again, like beating a dead dog, VD voltage drop is a major problem in our business, and I don't think a lot of technicians out there really know how to do that.
Yeah.
The boss gets mad and he goes, just put that part in the car. Meanwhile, it's a poor connection somewhere. And that's what you need to look out for, poor connections. So diagnosis that's not correct, that's a big one.
Right.
And there's that electrical faults.
Yeah, and we're going to go into more detail on that.
Exactly. And make sure a relay is a relay, the right exact one. People think, oh, we got 4 prongs on it or 5 prongs. It's the exact. Talk about this contaminated fuel here.
And we've covered that quite a bit. These are some really good illustrations of what is being found in these modules that are returned as defective. And it's not just significant to Carter. I mean, you can see here, it's very, very fine rust debris at the bottom of the well that's managed to work its way past the strainer. We're talking about microscopic particles here, but when they collect, they're abrasives. They're getting into that pump motor and they're just wearing it down.
Right. It's like grinding it up, like, you know, a little pepper mill. Now, we had one in here recently. I really should have, thinking about it now, I should have taken a picture out. We took a couple of cups with the fuel. It looked like this fine silt was in it. The filter, I cut it open after putting water through it, okay, so no one gets hurt. And it was just loaded with stuff just like this. In fact, with a motorcraft filter, because it was a Ford vehicle.
Well, I mean, come on, Jake. You've been in business a long time. I've done it for a long time, and I know a lot of the folks that are watching have been in business for a long time. You got the car up in the air, you see the fuel filter there, the car's got 100,000 miles on it, and the fuel filter looks like it's never, ever, ever been changed.
Very common nowadays.
Very common, sure.
What's maintenance? You know, so this is what kills a fuel pump. And you need to start checking. You know, we're going to talk about current ramping, something maybe not everyone out there has. Maybe people don't have a labscope. I mean, nowadays you really should. We'll show them that. But what we did do, we know you got a scan tool, so we'll be using a scan tool, and I have a little clamp there that just gives us some current.
Sure.
Now, at least that throws you into a ballpark, but it doesn't show us the important thing that we're going to go over later, using the scope pattern, is that armature worn due to contamination like this, okay, or even a voltage drop or whatever. You may not be able to pick that up with just a voltage or a current reading.
Right.
So that's where a labscope is going to come in handy. So dirt is a problem.
Here's a good example of what G was talking about earlier, just around the filler. You know, not cleaning this off before you go ahead and remove that assembly.
I don't know.
There's what happens. I mean, I even have a few armatures around here. I cut fuel pumps open,
Sure.
you know, with my little exhaust chain thing.
Yeah,
you
look
know.
at the impeller on that thing.
Sure. And you know, major cause is people run in, like we said, low. God forbid they put fuel in it. This is a submersible pump that needs to be in the liquid, good gasoline.
Oh, absolutely. Absolutely.
So, you know, look for dirt, and there's a great gas caddy that I've had. You know, you can put gas back in, but you should have a filter on this. That way you can filter out any kind of stuff.
Yeah.
You know, dirt here, removing the tank, you know, at least this picture's showing it right, with a jack, you know, instead of, hey, Bob, Jim, give me a hand. You know, these tanks are pretty awkward in many cases, and if they're full, and I can tell you, customers never, ever brought it in when they needed a fuel pump empty.
Never empty.
They gave me cars with drivability to test empty, but when they needed a fuel pump for some stupid reason, they seemed to like to fill it up.
Yeah.
Probably because they knew they had a problem, but they figured, I'm going to treat the car to a full tank of gas.
Yeah.
And then I got stuck with it.
I'm going to say a little tip here. When I pull in the tank, this is a little side tech tip that I used to use to make that a little easier. Sometimes you're stuck in a position where you have to do it by yourself. So you have the jack, the transmission jack works great just to support the weight. But when you get like these pickups with the long, narrow tanks, that fuel sloshes and can get out of balance very easy, go to the auto parts store, get you a couple of motorcycle tie downs. And then you can support those on the frame on either end of the tank, and you just loosen them up gradually either end so that the tie downs are supporting the weight on both ends,
right,
and you're not just trying to balance it in the middle. And you can actually get it to the point where it's hanging down a couple of feet, lower the vehicle down to where the tank comes into contact with the floor, and then disconnect your tie downs, and you get it out. You know,
that's a good move, but even with a jack like this, you still have that problem when it's real long, because these are, like the one we have here by Norco, has these little rubber bumpers on it. The tank fits in there. But again, with these long tanks with gas sloshes,
right,
if it's full, we use the tie downs.
Yeah.
And they work real well when we carefully lower.
Yeah.
Again, air operated, way easy.
I got a question from Anthony.
Anthony.
Anthony says, what causes a new fuel pump to crack where the plastic and the metal housing meet?
Whoa, what causes?
Got to be dirt or distortion, I would think.
So the question is, what causes a new fuel pump module to crack where the plastic and the metal meet?
Right.
Does he mean on the top, or does he
He
mean
doesn't say that here.
inside? I wouldn't know. If it's up top.
I would think they either, they bend the ring. I don't know if they can hear what I'm saying here.
Yeah,
I think you either bend the snap or the securing ring when they take it off and it cracks it, or
there are a number of when you're putting the ring back into place.
Should be a new ring, like I said.
Yeah, and how many have we seen? It's a three-prong or three-tang, however you want to refer to it,
right,
locking. How many of us seen the dull
punch
screwdriver in the ball peen to try to drive it around?
Oh, you mean they make tools for this?
Oh, yeah.
Yes,
So I would have to think a lot of times it's simply a matter of proper installation,
Yeah.
following installation.
Yeah, you shouldn't be banging on it, the old days of using a brass puncher, like you said, the old screwdriver. You
Right.
got to really know what you're doing, or many of these companies do have the proper tool for it.
Yeah.
Another question, effects of ethanol on pumps.
Well, that's a topic I don't think we have the time to get involved with tonight.
Ethanol could give you some issues. We've seen that. That's almost like the content of ethanol we have in the fuel, just to make it short, and it gets real, it's made for cold weather, but we sometimes have crazy weather. I know we've had it here, where you'll get a 60-degree day or so in February, a few of them, and what happens to that gas will let ethanol, okay? You start getting like a vapor lock, and boy, that will eat a pump up. So there's winter fuel for real, not like the people who used to come in and ask me, can you change my summer air in my tire to winter air? That we know is baloney, but fuel, there is summer and winter fuel, and sometimes when weather changes drastically, we could have an issue where this pump is getting like, almost like a vapor lock and ruin the pump.
Well, you keep
That's
on
what
that
I've
pump's
seen.
submersed in a module,
Right.
and it's got to get a good, clean, constant feed in order to keep up with whatever the pump's trying to deliver.
Exactly. And you mean if these people don't leave enough fuel in there, and then we have the weather change, then we'll have that effect with us.
Good, yeah, good, I guess so.
Yeah, I remember years back when we had a warm winter, that was a problem.
Okay, we've kind of talked about the effects of that debris clogging in the strainers and the filters, and the importance of changing that, so I don't think we'll
And it's even, if you just go back to that one
Back
second,
up.
when you start to see metal particles, connected to the filter, you're going to have to do a good clean out. Maybe the tank is coming apart. I mean, we went to a lot of composite tanks now,
Yeah.
obviously. But again, it's not a bad idea to look at the strainer and see what's there. Maybe someone poured in something. We've seen tanks with sugar in it.
Yeah.
We've seen some
Yeah.
weird stuff. By the way, if one dry gas is good, oh, 3 or 4 is better. And by the way, that magic, we'll pass your emission test with
Right.
XYZ cleaner,
Right.
they're gonna buy 2 of them, guaranteed.
Guaranteed fuel economy improvement.
So you gotta look out for this. Your customer sometimes doesn't always tell you the truth.
Yeah.
Unfortunately.
I once had just kind of a side note, I once had a customer come in complaining of no start code-in, and I know probably not the most professional thing to do, but checking for no fuel as part of the cause. You hit the little Schrader to look for the little squirt of flow gas. Well, gee, I hit the Schrader and this thing popped out emerald green.
Wow.
The tank had been filled with antifreeze by a disgruntled boyfriend, and the poor young lady
That'll do it.
was trying to run on antifreeze. That didn't work.
Didn't work. Well, she could have had something there. It did work. Hey, what we should do maybe about now is, we're talking about wiring and so on here right after this. Maybe we should just show them activation with their scan tool. Take a little break from the slide and show them using the amp clamp and explaining that.
Well, I mean, that's a great lead-in, because we're going to talk about a very, very common reason that new fuel pumps fail again, or the new fuel pump installation doesn't cure the problem, and that's electrical issues that are missed. I know one of the ways that you've been preaching on this evening, and I certainly agree with, is when you're troubleshooting that fuel pump, you got to do a voltage drop test. You got to do a voltage drop.
How many of these have you guys seen on top of pickup trucks where you can see it's all moldy, it's all rotten? If you lift that wire up, you are going to see voltage drop like there's no tomorrow. Everyone out there should have Stabilant 22. Stabilant 22 is a good contact limit, at least to try that. When you have a connector like this that's something burning up, we see it melting, you should not put another pump in there right away. We should look for different types of problems that may have caused this. I mean, here, we may have a pump binding up melting us. And if you put this on the brand new pump without maybe changing that connector, you may run into a problem.
But again, pointed out on the new one, if you have a connector that looks like this, and you plug it into a nice, shiny, pretty new one, and you damage this end, what choice do you have? You have to replace the module.
The whole
now
module.
for something that wasn't the module's fault.
You know what you hear from a lot of guys, well, this is not really that accessible, from the parts store or maybe the dealer. Well, a lot of times what you can do here is take the pin out. You should all have those little pin tools, computer pin tools. Take this out and make sure you put a new connector on it and put it in, and make sure this thing is down right on the terminal if you couldn't get it, and seal it up with a good weather pack here and maybe some of the dielectric type of grease so no moisture gets in there. And you could also, I've done this sometimes where I couldn't get them, you could put little pieces of plastic to hold the pin in tight, little, something that it's not going to cause any problems. Better if you could buy the connector and change it.
Sure.
Definitely. But
Sure.
sometimes we know you can't.
Well, let's see, I'm going to bounce up a little bit here to this one to help you when you're showing these guys just how to do that voltage drop test.
And that's, by the way, that's important here. You can see Carter at www.carterfueldelivery.com. They have a whole fuel pump type of guide here. And
A lot of resources there.
look at this fuel pump voltage drop test where we can test negative to the most negative, positive to the next negative. We're doing a voltage drop on the negative side, okay? And then we can also do the positive side of the setup. Positive to meter the most positive, negative to the next positive. We can see if we have a drop. For those who don't know what voltage drop is, if you're rusty on it, basically when you're putting a lead like this, it's almost like voltage is pressure, a pressure gauge to see where we have loss. If we have full pressure here and less pressure there, if it was a pipe, we would know we had some sort of a leak or some sort of a clog, right? Same thing with electricity. And I think we should give a plug for ourselves to go and look at that voltage drop video if you have a problem besides looking at this Carter fuel pump.
Yeah,
Question.
A question from Frank. He says, why are manufacturers going away from external fuel filters?
Oh,
Good question.
Frank. Frank brings up a good one in case you couldn't hear Pierre. Why are manufacturers going away from external fuel filters? Well, I'll let you go first if you have an answer. If not, this is just what I've heard. They want to keep everything. They really think the pump, the fuel filter, and the tank should be replaced at one interval when you have 100 and some odd thousand miles on this car. If you keep everything full, if you don't dump anything in there, it's more of a modular type replacement. And I think in a way, you got to realize where they're coming from. BMW at one point with bladder tanks. I can tell you the Prius tanks with bladders, the Chevy Volt. There is no replacement part other than you're buying a complete unit. Why? Because of what we went over before, contamination. Someone not doing the job right. Someone putting that metal ring on, banging it, we said, right?
Yeah.
There, a connection loose somewhere. You know, you had a couple of slides back there, if you don't mind for a second. Loose connections. I can't tell you how many fuel pumps I've seen where the connectors were a problem, okay? So if you have to buy something all in one piece, by the way, isn't it the same thing with the module? We used to change the pumps years back when they first came out with fuel injection, right? And what happened? Well, the sock didn't fit right, or you used the old sock, you didn't have the right connector. Oh, use connector terminal A, B, C, or D. It looks like you were playing a crap game because you had a whole bunch of little terminals to connect.
Yeah.
That leads to problems.
Well, let me say this too. I mean, for the guys and gals who are watching, this is not directed to you. You're obviously doing everything you can to do the best job you can, or you wouldn't be here with us tonight.
Exactly.
But I believe in being realistic. There's 750,000 men and women doing our work.
And we don't have 750,000 people.
We don't have 750,000 online with us tonight, and I don't think it would be out of line to say that there are a few in our business that probably should seek other career options, because this is that's why you and I are seeing these kind of issues
Exactly.
in our shops. These are problems where maybe the fuel pump was better, but because that connection was not repaired at the time taken to repair it, at the time the new pump was put on, that customer is having the same problem, but now instead of a few years, it's a few months.
Right.
You know.
And if the original one lasted, 10 years, why is this new one going in 8 months for argument's sake?
Right.
I think there's a lot in our business, not to take too much time up, where everyone shoots off the head. Oh, I know that particular vehicle has a fuel pump problem, just throw a fuel pump out.
Right.
That's not testing, that's guessing.
Absolutely.
And we need to test, not guess.
Absolutely.
Pierre, do you have any other questions, or we're good?
No, I'm answering a question just online.
So this is very, very important to look at connectors, make sure wirings are good. The other thing I like to mention is clamps. When people put on the external pump, they use a screw clamp. And people sometimes, mechanics like screwing things, the rubber starts coming through the band on the clamp, it's too tight. Okay? Then what happens? It's like a bad check valve in the fuel pump. You get extended start. Quick tip, if you have a cart that you have extended start, turn it off, 2-second activation, shut it off, do that about 3 times. The 4th time, turn the key. If it starts right up, you have either a porous hose, someone tightened the clamp too much, or your check valve is bad, or there's a hole in the line.
Right.
And by the way, do not forget those little O-rings if there's some sort of filter external, not many nowadays, but in case you're doing that. Sometimes you won't see the big fuel leak.
I have a comment related to somebody contaminating fuel.
Oh,
We had a new fuel pump fail in 1 week, and when we dropped it to take the filter out, it smelled like vodka.
Okay.
Where were they?
One of our members, our audience members, has just made a comment that he had a unique experience with contaminated fuel. Fuel pump that failed a week after installation, and it smelled like vodka in the
They didn't
gas
invite
tank.
us to the party. What are they doing?
What a waste of good.
Good vodka.
Good vodka. Yeah, just call Pete and I. We'll be there.
It might have been cheaper than gas at the time. Who
It
knows?
could have
Could have been.
They figure alcohol, I don't want it. Okay, let's, do we want to do the clamp thing? So we just show them the little
Yeah.
clamp. But by the way, we're going to shut this battery charger or battery maintainer off that we have in the background right now. Woo!
That makes it nice and quiet.
That was keeping me awake, Pete. I'm going to turn the key to the on position. I just want to show the audience, we're good, what we have here. This is a little inexpensive type of clamp. There's many different brands out there. And I'm just going to zero it. And this little amp clamp, I'm going to put around a little fuse buddy here.
Now the fuse buddy is just simply put in place instead of the fuse that feeds the fuel pump. If you're going to use that particular location to do these tests, you want to make sure that you know what else that fuse is feeding. It may feed other circuits as well, and that'll affect your reading, of course. But
Exactly. You mean like on some Chrysler products, they have an ASD, the auto shutdown relay, that fuse may power up, could go to ignition or injectors. So we're going to take our scan tool, and one of the things, doesn't matter what brand you have, you should have this in most scan tools that have activations. Whether it be the red guys, the blue guys, or in this case, the orange guys, little land scientist here. We're going to go to activations. So on activations, we're going to go to activation menu. Now here's where you can do fuel injectors, but we're not going to do that here. We could do this and check fuel injectors for leaks and so on, but what we're interested in is actually a fuel pump relay. And right there's my fuel pump relay. I'm going to activate it. And it tells me, am I sure? I heard it click on, I heard the relay. The pump is running.
the pump running.
And a little tough, but let me see if this has a hold on it. Got that? Okay, I hit hold. I have, give me a second, we have tons of wires. I'm going to try to put this here so it's easy to kind of zone in. 6 amps, 538 amps. And this pump varies on this vehicle. We're just running it right here. So we can see that this pump that's about 58 PSI to 60 something PSI is falling in the range of 6 to about 7.5 amps or so is kind of normal on this. This vehicle has about 130 something thousand miles, original pump on there. Now, that being said, if we had a pump that wasn't pushing a lot of fuel, current would go lower. If I had a clogged fuel filter or supply line, amperage would go higher, correct?
Now why is that?
That's because we have mechanical resistance on the fuel, on the amperage going higher on the fuel filter or line being clogged.
So yeah, because the pump's got to work harder.
Right, way harder. Yep.
Question from Eugene. A little kind of related, but not right on it. He says he's never used his Modus to check a fuel pump. How would he hook it up?
Okay. Question asked by Eugene, how would he use his Modus to check the fuel pump? Well, no different than what Pete has set up here tonight, is using a amp clamp. You can use the Snap-on brand, Mac or whatever, but here we have a Pico or PDI, they're all the same, or E-scope, everyone's using a PDI. Okay, you would buy one of these and go to the first little click, which in this case would be the 20 amp or 100 millivolts equals 1 amp. They would then zero the clamp, put it on, and then go to their scope in voltage. So on a Modus, yes, there's a few ways. You can use the Snap-on setup of the low amp clamp, if you buy their amp clamp. You buy the generic amp clamp, very, very inexpensive.
Mm-hmm.
You know, you can get this from quite a few people out there. And then all he does is put, let's say, 1 volt per screen. And he would see what amperage this pump is pulling out.
And we'll cover that in detail.
We're going to do that.
The scope test. We'll
So
show you
hopefully
this
that answers his question.
Sure.
You had it down like this, right?
Well, we'll find out.
We'll find out. It'll be right or wrong. And by the way, the noise that you don't hear now, that I could hear myself, we had a battery maintainer on, which is important to do when you're playing with scan tools or leaving the key on for any extended period of time. And we're not talking about a regular battery charger out there.
Right.
We want something that'll maintain it, just so you know.
Right.
Okay, what's our next thing? that we want to do, or any questions there, Pierre?
No, there's one comment though that you may want to comment on.
Comment on a comment.
Comment on a comment.
Jim Haynes says, I've been using a 6014 bulb with both elements wired together to load test fuel pumps.
Okay, well, here's a comment on the technician is using a headlight.
A headlight.
To load the circuit. And, you know, there's nothing wrong with that. If you're going to take the time to access the connector at the fuel pump, and then you want to load the circuit and perform your test there, that's fine and dandy. I kind of like to leave the load that's being operated in place, so I can identify whether it's a problem with the load itself, the fuel pump itself, or in the circuit. But if you just want to test it, in fact, let me just grab this real quick.
Sure. Yeah, and there's a couple of ways to do things. You know, I used to use the headlight test to check modules out to see if they would really pull the correct amperage on a coil pack on GM, in fact.
And that, actually, thank you very much for the question, because that was a very good lead-in
To this great tool.
for this tool that Carter has designed. Like you were saying, and we know, a lot of technicians are not comfortable with voltage drop testing. MotorAge.com, community, keyword voltage drop, lots of stuff there to fill in the blanks for you. In fact, that was the very first webinar that we did together.
Yes, that was our first webcast. That goes a couple of years ago, or a year ago, or who knows?
Yeah, 2 years ago in February, so wow.
So it flies by.
Anyway, this tool has a little microprocessor in it, and when I first saw it, I'm thinking to myself, okay, this is setting a voltage in one end and seeing what's coming out the other, and you know, I was mistaken. This is a high-tech tool. This is actually connected in place of the fuel pump. Once you've accessed the connector to the fuel pump, and they have numerous adapters for you to be able to connect it. And there's a 15-foot lead that goes with it, so you can sit in the driver's seat. And what this tool does is it looks for two things. It looks for, number one, what the peak voltage is, and it loads the circuit in order to measure that, and how fast it takes to get there. So if there's a problem with resistance of the circuit, of course, peak voltage is not going to be where it should be.
Exactly, you'll be
And
lower.
it's going to take longer to reach it. So this test is only 300 milliseconds, is all it takes. And the way you use the tool is once you have it wired into the harness, you turn the tool on, and then within a few seconds you have to turn the key to run, because this is already beginning its test. And if you wait too long, it's going to assume that there's a resistance issue, and it's going to flash the red fail light. If you go ahead and turn the key on and there's no problem with the circuit, the little green light will flash. They do recommend you do it twice. You go wiggle the connectors at the pump one more time, do it one more time. If you get two greens, then you're a pretty good bet that electrically there's nothing wrong with the circuit.
Which is important. And this is all because many people don't know how to do a voltage drop test. Right. So this is an alternative with many connectors that can work. Question here.
It's actually not a question, it's a comment on the vodka smell.
Oh.
And it's a guy, Harley says, vodka smell equals methyl hydrate overconcentration, which is too much gasoline antifreeze in the fuel. It is still a fuel problem, but it's actually somebody mixed too much of the gasoline antifreeze into that fuel.
Oh, so like I was talking about before.
Right.
Yeah, and I've seen it, by the way. You know, not thinking, I thought he meant someone really did put vodka in.
No,
So
that's a good point.
But
That's good.
yeah, I've seen people actually they would tell you, yeah, I had a little bit of a problem, so I put 4 cans of dry gas, I had them on sale,
Yeah.
and I thought that would help my car run better.
Yeah.
And we know that's not the case, so.
And the little ringing bell in the background, that's just because it's such a popular garage here in New
That,
York.
that people
Are
call.
calling all hours of the day and night.
Even at 8:44 at night, they're calling. So we apologize for ringing in the background. It's not ringing in your ears, by the way.
All right, now, how about we do something?
Well, first we should look at the circuit here.
We're going to take a look now with the scope, and I guess I had a kind of a strong penchant for that. I wanted to do that in this particular webinar because we did a fuel system about a year ago.
Yeah.
And we focused on mechanical. You know,
That's
the
correct.
mechanical gauge, the importance of volume testing, which I'm sure everybody here watching tonight understands. You have to check both pressure and volume in order to gauge the health.
Exactly.
But you know, as a tech and on flat rate, I want to be quick, I want to be efficient. If I'm diagnosing a drivability problem that I think might be related to fuel, I want to know about the health of the pump, I want to know about the state of the injectors, what the pressure is, anything weird going on, And today, with some accessories, the scope is a very
Sure.
useful tool for that.
Because you're testing the whole system, from the delivery of the fuel from the back, the pump,
Sure.
up to the injectors, the whole system.
Sure.
And that's good to do.
And if I can do
That was
this
the last slide.
in a matter of minutes rather than hours, then gain a lot of information in a quick amount of time. At the very least, I can perform this general test to lead me to the pinpoint test I'm going to focus on to narrow down whatever the problem might
You know,
be.
in the 90s, Don Schnell, myself, and a few others, when we did current ramping, it was exactly for this purpose, to see, real quick, here's my fuel pump, I can either go to the fuse, or I can go to the relay, and quickly, if I jumped at the relay 30 and 87, I put my amp clamp on it with a scope, and bingo, I can tell if this pump is going to be a drivability issue. You know, is that contributed to it?
Mhm.
And this is without taking, you know, fuel connectors, they're a little bit of a pain in the butt, right? They could be in hard to reach places. We know on some cars you don't have every connector.
Right.
And it saves you the time. I mean, when we started compiling information, we know because we did fuel volume tests as well as pressure tests, and what we found, the amperage would put you into the ballpark to know, is this good or bad? Or do I need to do all this work? So why not do that? And that's what we're going to do tonight. By looking at your wiring diagram, like Pete said before, we have a fuse out, a 20 amp fuse for the fuel pump. We made sure there was nothing else on the circuit. And what we're doing is we're going to check the pump, and we're going to see that tonight on a picoscope.
Yeah.
We had two people ask what brand of scan tool you're using tonight.
This is an Autoland Scientech iScan2WT. Okay, but we can do this with OTC, we can do this with Snap-on, we can do this with Launch, we can do this with Auto Ingenuity, we can do it with a lot of tools.
Yeah. This
You
is
know what a
very,
lot of
very
people,
basic
it's a
actuation.
very basic, I mean, this tool does a very good job. I mean, on this you can get into a lot of different things, but I think a lot of people out there don't know what their tool can do because they don't explore what the tool does.
You know, I mean, I'm really glad you mentioned that, G, because one of the things that we tend to try to stress at Motor Age in our features, and I know you guys at TST do, you don't wait to learn your tool when you have a problem. You know, you want to take out, if you have a scan tool that you're fairly new to, or maybe you haven't explored all the possibilities with,
Exactly.
hook it up, take the time to the known good that's coming in your shop. Same with your scope. You know, if you have one on your Modus, if you have a Pico, if you have the E-Scan, if you have any of these products that are on the market now, and you're only pulling it out when something's wrong, you're not going to become as good with it as you should or could be by using it on known good. I had a great comment from a seminar I presented a while back from a guy that told me, he says, you know, one of the reasons that I didn't use my scope was because I had to get it out of the box, I had to hook everything up, I had to turn on the laptop, whatever else I had to do to fire it up. And sometimes I just didn't feel like going through all that trouble. But then he turned around and he made a habit of starting it up in the morning with all of his other equipment. So it was on his workbench, ready to go all day long. Then it was just a matter of grabbing the leads like he would his multimeter and connecting.
And you know, that's a very important point. Usually what I have a Fluke 196 C-scope. I just press the button, starts up, and I can get instant readings.
Mm-hmm.
When I need more power, either I'll use a Pico, or most of the time I'll go to an E-scope, an 8-channel scope with bi-directional. But if I didn't have it started up, I'm just going to go to a tool that I can instantly turn on.
Right.
And I think that's what guys out there, if you're running a shop, you should turn on your computers during the day, and at night if you want to shut them off, hey, that's great. So, labscope. So another question for...
Question from Rick. He wants to know, when doing a voltage drop, would you recommend connecting directly from B plus all the way to the pump to test the entire circuit?
Absolutely.
Absolutely.
Yeah, the comment was from Rick, do we recommend in a voltage drop test, if we're going to check the positive side of the circuit, should we go all the way back to the battery positive terminal? Absolutely. You have to check the entire path. Here's a great example. Check out this schematic, G. Where's the ground on this fuel pump?
G350.
This is a
way
body
in the back.
ground.
It's a
This
body
is
ground.
body ground, which means the body of this car, the whole body of this car, is the path back to the battery. How are you going to test that? By simply connecting to the ground at the back of the car. You know, you want to check the entire path. Very good point. I'm glad you brought that up. Another plug, watch the February webcast,
Right.
And we'll show you why that's important.
And, you know, the other thing I'd like to say there, Pierre, is I use a power probe that I stick at the battery, knowing that, number one, if I touch ground with it, I can pop the 8 amp breaker, meaning I have a good connection at a battery. But sometimes certain clips on the power probe, you have a dirty connection, it's not really good. Then I take that, I bring it all the way back to the car with my meter, and there I'm going to do my voltage drop test.
Sure.
Because it's the exact same setup.
And if you don't own a power probe, then
Jumper
go out
wires,
and
whatever.
get you a 20-foot section of
Lamp
wire.
cord, yeah, lamp cord works.
And hook it, make it so that you can use that as your reference point
Right.
anywhere on the car.
You know, another thing I want to bring up about this body ground, the GM vehicles, late 90s, early 2000s, G405, that was the ground number stuck in my head. I had a car in this very same bay come in, a shop left it to me, and they had changed computer injectors, ignition, you name it, okay? It had a bunch of stuff in there. And the complaint of the customer was the car did not run good on bumpy roads or when they came to a stop. So first thing I always do is look at the car, make a long story short, I start it up, I walk around, car had the high idle because it was cold, went down, car's running great. What's the next thing you do when you get in the car? I step on the brake. I notice the car's running nasty because I got to put my foot on the brake to put it in gear. I pull it up to this very bay. I put my foot on the brake again. It starts running nasty, put it in park. Now it's running good when I take my foot off the brake. I bring it in, and if you remember the GMs, under the hood were the relays for the fuel pump. I took out my labscope and my amp clamp, clamped it on there, looked at the current draw. The current drawer, the humps of the pump were good because you know what? They changed the pump. You know what the problem was? G402, not this G350, was the ground on his GM vehicle for all the lights. It had 14 loads, 14 light bulbs. And guess what? Some of them were brake lights. And back then, the big bulbs in there,
Sure.
they'd suck a lot of amperage. Here's what happened. The humps were nice and goody, goody, good. As soon as I stepped on it, the amperage went down from about 6 amps down to about 4 or so. Foot off, up and down. The problem with the bumpiness, the brake pedal adjustment for the switch was loose. So when you went over, you know when you see some of the pedals loose?
Yeah.
The light was coming on, putting the loads on and dropping it down.
Yeah, and gosh, you know, this isn't a voltage drop webinar, but I can't begin to stress
How important it is.
You see the result of what can happen to the electrical circuit when it's actually working. It's under the load. That's the way you need to test it if you're going to find
Exactly.
the issues on today's cars.
And not disconnecting stuff. See, I'd rather do stuff like this first. What's it really doing when I clip around this wire? Because once I open it up, I may have cleaned a poor connection problem.
Sure, sure.
And that's why I don't like going in it until after I do all
Right.
the easy tests.
Right.
Another question.
Yes, Tucker from Utah is going to school for automotive. Has
Hey,
a
Tucker
question.
in Utah. I wish I was there. Maybe skiing and
Yeah,
stuff. Park
probably
City.
Vehicle with almost 200,000 miles, does not have any problems, but has never had the pump changed. Do we recommend just preemptively changing it, or how would you test to see if it was close?
Here's what I'd recommend. Someone out there in Utah has a vehicle with 200,000 miles. He's asking if we should change the pump, even though the vehicle has no problem. I would say I'd rather current ramp the pump and go against a known good. You know, depending on this vehicle, if it was a Vortex, 9 to 11 amps, I know is a great range. Okay? That 2 amp range is good. If he's lower, he's in trouble. If he's higher, he's in trouble. So if he knows what type of vehicle he is, a lot of them I still have in my head, depending on the year of the car, you could see what that current reading is. If he is able to capture it. What was his name, Pierre? I'm sorry. I still get names.
Tucker.
Tucker. Tucker, if you want to email me, if you have a scope, and you let me know the year, make, and the engine size that you have, I'll take a look at it and let you know what I think. Because I've done a whole bunch of current ramping. I think it's a good idea to check it. Why change something that's not bad?
Sure.
That's my opinion.
Sure.
You know, I had a car, in fact, I sold it to Craig, okay, for packed with peanuts. And he sold it, made money on it. But it had 375,000 miles on it. The fuel pump was original. No lie. You know why? I never ran on fuel. It happened to be a good pump to start with. So nothing's impossible when we take care of stuff,
Sure.
maintaining a vehicle.
Sure.
So, any other questions, Pierre, before we move on? Okay,
Nope.
so
All right, well, let's get right into it. You know, we've
Wanna
got
know
the
to start it?
scope set up. We'll just kind of go through some of the setups. for those of you guys who are watching. Haven't been using the Pico tonight. We've got 3 channels working.
Do you want to activate it first so you can see the difference?
Oh, no, we'll go ahead and try that. Channel A, the blue channel, the blue trace that you see down here, is set on a DC scale. It's got an attenuator, 21 attenuator in line. And the reason we have that is because this is going to the number 1 injector. It's going to the ground side of the circuit. That's the control side. That's what's going to give us our pattern. And we're really not going to be diving into injector diagnostics so much. What we're using this for is a reference point. Because whenever I trace out the other elements on the pattern that I'm going to share with you in a moment, I want to know where in the engine cycle that is. Is it associated with cylinder number 1, 2, 3? In our case, we're dealing with a 6-cylinder engine. So if I do see an anomaly in that pattern, that reference point is going to help me isolate which cylinder is being affected by that anomaly. So that's the blue trace. The green trace is going to be our pressure transducer. We'll just read behind you there, G. I'll share that. Tonight we're going to be using the Pico pressure transducer. It has 3 different ranges. We'll be on the low end tonight for what we're testing. But one thing I like about this is I can test liquid and
vacuum
pressure, vacuum pressure. The same one I'm using tonight for this fuel pressure transducer, I can also use to do in-cylinder pressure testing if I want. But there are other branch transducers, so this is just happens to be what we're using tonight. And then finally, the red trace is something that many of you are already familiar with. G shared with you already. We have a low amp current probe. We went ahead and identified the circuit that we're going to attach to, fuse 24 on this particular vehicle. This is an 04 Jeep Liberty with the 3.7. This fuse feeds the fuel pump circuit. Certainly you can bypass the relay and test there, but if we leave the relay for testing at the fuse, then we can check everything for an issue.
That's correct.
Okay, so that's what we have set up. This is set on the -5 to 20 amp scale. Using a 50 millisecond time base, which means every square here is 50 milliseconds apart. Yep, we have that on number 1.
And let me know, I'll start it up. We've got a hose on it, we're ready to roll.
Yep, well, we're going to do it first. We're going to go ahead and hook up our gauge.
So we already have something on the fuel rail. That's a Schrader that connects into our pressure transducer.
Well, what's the nice thing too is that all we're doing is, instead of using the mechanical gauge, it's the same connection to the fuel system. But instead of hooking the mechanical gauge, I'm hooking the electronic one.
Sure.
To it,
So this is no different. Some of you people may have the old PV300 or PV500 pressure transducers, or maybe an old machine, like a Sun, a Bear, or an Allen that had pressure transducers as well. So we have the amp clamp on. You just let me know when you're ready, Pete, and I'll crank it.
Got to get our number 1 injector back up here.
That's what happens when you're moving around. Stuff falls off, probably my big foot banged into it.
Now, as a side note here, on the injector, we're using something that you can pick up at any sewing supply. They're called T-pins.
T-pins work great.
A little T-shaped pin that you can use as a back probe connector. That way we're doing minimal damage to the harness.
Right. We're not piercing. We're going in the side of the weather back.
Right, and if you have to, absolutely, if you have to pierce, for example, if I wanted to take this on a road test, I'd probably want to use a piercing probe in order to help secure that in place. But when I'm done, I'm going to take some liquid electric tape and seal that hole back up again.
Well, I'll do you one. I'm not a piercing guy. What I would do is either wire tie it
That's
there,
a good idea.
or there's a piece of tape around it, even better, with my lead, a little tape, and it doesn't go anywhere.
It's secure. Good
So-
idea.
Okay, time to start it up.
So we'll crank it up.
Here we go.
Put that way. First, we need our pressure transducer.
There we go. We got some nice readings there. There's our injector. Our green was the pressure transducer.
Well, here's the nice thing. I hit the button, Now this is frozen on the screen. I can go back and shut the car off.
And then we could diagnose it. That way we don't have to yell.
It's not frozen.
Oh, didn't freeze.
No worries.
He's going back in time. As he's looking for it. But we could freeze it. You could put a hold on it and then diagnose it.
That's the beauty of live webinars. But no
So, you know,
worries, we'll get it right back.
When it's live, just like what happens in your shop. While Pete's looking for this, again, you know, when you work in your shop, stuff happens. So here, it didn't freeze on the screen, but it is back there right now. So we just took a
Before I
moment.
had a chance to save the file, I have another one saved, same vehicle, okay? But yes, what I want to stress here with the scope is that it only took a few minutes. Once the connections are made, it only took a few minutes to gather all this information. Now I can take a look at it in more detail and see what.
And let me add something here, Pete. You notice, if you looked at what we just had running a second ago, this looked a little bit different than it currently does now. So sometimes a cold motor, warm motor,
Can have an impact.
you could have a little bit
I
of
think the
impact.
time base might have been a little different too. The RPM of the engine might have been a little off or something.
Yeah, it
different.
could be, because we were
Okay.
actually in 4 injector events
Right.
on the one.
And it
it's
just-
the same setup.
Yeah, same exact setup. So
Yeah.
no difference.
Let's take a look at what we got. Again, what we have here is we have the blue trace is the #1 injector. I'm also using that as the trigger point, and let me differentiate. The trigger is when I set up the scope to start drawing the pattern.
Correct.
And I can set that in a variety of parameters, and it varies a little bit from tool to tool. You can check with your owner's information for the scope that you use. But that's a little different than the reference. You know, the reference tells me where in time I am in relation to the other patterns. So that's what I'm doing. I'm using that as the trigger and as the reference for the other patterns on the screen. Gee, why don't we talk about the one that we all have some familiarity with already? Let's make it easy. And one of the things I like
And we're going to look at the current ramping.
Now, we had a couple of people ask before,
Okay.
what is the correct, and I answered some of them individually, what is the correct current for a particular car? And maybe you
What
can talk
is the
about
correct current for a particular car? Well, there's all different calculations that based on every pound of pressure, and when we did a webcast on this, I don't know, it was a year ago, whatever, we went into some of that, but I got to caution you. On the generic type of so much amperage for every 10 pounds, that doesn't hold true. For argument's sake, if you did that and looked at a vortex engine, it would not come up to the amount of amps, because for every 10 pounds, if it's 60 pounds for a vortex, 6 amps, and no way in hell that's going to run like that. That's a 9 to 11 amp pump. It depends. I would say your best thing to do, because there's so many different vehicles out there nowadays, is to get a known good with an original equipment pump, no problem on the vehicle, okay? And start saving stuff. This is what I did years back, and this is what we did in a program called the ATTACS program, that we saved 100 and some odd cars of current ramping. So the quick answer is, there is nothing really published out there that's going to give you the current for that fuel pump. And there's a couple of reasons. We got variable speed fuel pumps.
Yep.
Okay? Now these fuel pumps, if you check it in your bay, well, they're going to get one reading. Why? We don't have a whole bunch of fuel delivery needed at that point. Under load, when it sees vehicle speed, it sees air coming through the mass airflow sensor or engine load through a speed density, like a MAP sensor, that's going to change the current. So you would need to know what car you're working on, do it against a known good, try it with a new car to fuel pump in there, and then you can see, hey, this is a known good, I got no fuel delivery problems. My fuel trim is actually good, right? Because if we have a bad pump, fuel trim could be off. We're going to be adding, right? So the answer to that, Pierre, is there's no real answer. It's exactly what I said.
Yeah, and I'm going to add a little bit to that as well. This is a general test, and I think our Jim Morton explained it a very effective way. There's general tests there's pinpoint tests.
Pinpoint tests.
The general tests are the ones that you try to minimize the amount of time invested gathering the most information possible to help lead you to the culprit. And then the pinpoint tests are used to put the final nails in that coffin, to nail that suspect down to the final cause of the problem. So these are all techniques that this evening on the scope are just a few ways. You saw how quick we could gather the information. Just a few minutes to get the data on the screen, lock it in place. Now I can take a leisurely look at it to see if there's anything in here that will lead me further down the fuel system path, or take the fuel system out of the equation for the drivability problem that I'm trying to diagnose.
Right.
And as you mentioned, just as a side point, the Carter pumps use a different, they use a turbine type pump wheel, which can actually cause a little higher RPM and a lower current draw than the OEM pump might have had. So that's a factor. You may not know if that's a replacement pump in this vehicle. I mean, this has got 135,000 miles on it. I don't know if this pump has been replaced in the past with an OEM unit or an aftermarket unit or a white box unit. Who knows? So we have to take that into consideration. And let's start. I mean, here we have with the current pump waveform.
And when you're blowing that up, I'm used to say one thing, what Pete was just saying, we really didn't prep a whole bunch of stuff. How hard is it to actually, the hardest thing was? Going onto the Schrader valve, we had to get down near the air box on this 3.7.
Yeah.
It's near the air snorkel. That was hard to screw that on. When we say hard, it took me 5 minutes.
Right.
To get to an injector, how long does it take? You got two little wires that you can back probe next to, right? So you're going in the side of the weather pack, and you got a 50-50 chance. Either you're going to be on a straight line of voltage, okay, that's the feed coming in. It doesn't go down, you switch to the other one, providing, obviously, we got trigger and slope that is set correctly on your scope. And with automatic setups, there's not a problem. The current rampant, all we did is go to the outside box and find the 20 amp fuse after looking at all data or any other wiring diagram, I guess you could go at it. It's that easy. So really, for you to hook all of this up, take 10 minutes, and you could save this. The beauty of something like a Pico, an E-scope, something that's a savable database, but even like that gentleman's Modus. He buys a little CF card that goes up top, you hit save, he can take it, put it on his computer, print it out for the customer. This is valuable, valuable information. And it answers that other question of how do you know when something's good or bad?
Right.
You need to test. You need to play the comparison game.
Right.
Just like here. And why don't you explain what we're looking at, the Humpty Dumpties?
Yeah. Now we're looking at current passing through the fuel pump circuit. And current's going to be pretty much the same throughout the circuit, no matter what we tapped into.
True.
What's causing the variations that you're looking at on the screen here are the brushes and commutators contained within the pump assembly, because it has to pass from one segment to the other. So that's what you're seeing here. And what this is giving us indication of is the overall health. And this is something that might go back to the student who was asking earlier about that 200,000 mile pump. If you see something, this has got some wear in it. Obviously, the peaks are not uniform. You can see several discrepancies here.
Yeah. And the big difference is, depending on your divisions here, more than a division or so from the lowest to the highest indicates something is starting to go on. Okay. And also they should be warned when you put a brand new pump in, it needs to break in a little bit, maybe a little choppy at first.
Right.
Okay. So you got to keep that in mind as well. But again, you can see we got a low, we got a high, we got a very high, we got a low.
Yeah. And then we can get an indication of the amount of current that's being drawn. Okay.
And if you go to the highest here, well, you have something on that peak. And again, we don't know if that's just a glitch, but sometimes you will get a little anomalies on some things. But I would say the average here is somewhere in the 8 amp scale. When we use that quick little current clamp, that right over here, we had under 7 amps just a minute ago. But it does make a difference on this vehicle. I noticed when it was hot or cold. So this, just like a meter, averages stuff, right?
Right.
The scope, we're looking at the high peaks to see what our average current is.
Yeah. And keep in mind too that your scope is going to check that current a whole lot faster
Way better.
than a digital tool.
That's just a quick check to see if we're in the ballpark.
Oh, absolutely.
This is putting you at the bases in the ballpark to see exactly what's going on.
Well, I'll ask you a question. We've also had situations where we come in with a car that is not delivering fuel oil. Okay, and maybe you can hear the pump, you can't hear the pump run, so automatically we think fuel pump. Anybody out there in the audience ever take a hammer and beat on the fuel tank to see if they could get it running? Don't lie.
Many, I bet.
You know what? If you do that to a modern pump, you can actually ruin the pump when there was nothing wrong in the first place.
Sure.
You can shock it enough where the permanent magnets inside can become dislodged, and you just broke something that you were trying to fix.
I got a couple answers.
You
One
know-
said bingo, one said yes.
So,
There you
at
go.
least you're honest. Thank you very much.
There you go.
And the big thing is, does it have fuel in it?
Right, and that's what we were talking about earlier. We can have a half a tank reading on the fuel gauge, but how many times have you seen that mean nothing? The tank's actually empty and got towed in. I can take that little low amp clamp and I can wrap that around that relay, and if I'm getting 6.5, 7, 8 amp reading, the pump's running.
The pump's running.
The pump's running.
If I have 1 or 2 amps, you may be running, but it's not pushing anything.
And let's talk about that, because you just hit a key there. If electric motor doesn't have to work very hard, it takes very little current to get that thing to spin.
Exactly.
So an empty tank, or not even an empty tank. What if that strainer is so clogged that the well can't stay filled?
Very good. If you don't
think
have
you
the
can run out of
well,
gas while you're driving down the highway and you still have a full tank of gas? Yeah, absolutely. Because if it can't get to that well, you can cruise down the highway at 55, and all of a sudden you start sputter, run out of gas, and pull up the side of the road, maybe 30 minutes, and start right back up again.
and then, from the low current, and then we'll get to the question, from a low current of someone running this thing dry all the time, you know what's going to happen? You're going to run into a high current, because you're going to ruin that pump.
Sure.
And that's what you got to be careful of.
Sure.
Question?
This wasn't a question from here. This is a comment I wanted to make. European cars with jet pumps. You have to be aware that there is a Venturi-like device that cross-feeds fuel from one part of the tank to the other.
Right.
And if fuel pump volume is bad, or if there's a restriction in the system, the jet pump itself is broken, you'll run out of gas when there's still fuel in the tank.
Yeah, Pierre's our
Excuse me,
European guy. Of course, if you work on the Euro cars, and not just the Euros, some other models as well, that use the saddlebag type gas tanks. Where there's one half and it overlaps the top of the drivetrain and the deck in the lower half. And they have a jet pump in one side to keep the main pump filled. Hey, NASCAR has one to keep their pumps filled.
Right.
And so when they're going around those banks, they can keep fuel funneled to the center. So it's the same principle. If there's a problem with that jet pump or a restriction on that side, then again, you can run out of gas with a full tank of gas.
It may not even be a saddle tank. They have sometimes a small well, a section, and then the main tank. Just to prevent sloshing causing problems.
That's right. Now, here's another thing, just real quick, because we were asked about how do you know the pump is good or bad. Let's say you don't know what pump was replaced in the vehicle. We can do the current ramping, but one of the things, and make sure we got the right pressure, but what you really need to know, do we have the right fuel delivery, the flow? And a little rule of thumb, just pop that over there, a little rule of thumb is basically for a 4-banger, a 4-cylinder, you really want at least 4/10 of a gallon. Okay? If you can't get flow of 4/10 of a gallon, you're going to see you got an issue and your current's going to be different.
Yeah, and that's per minute.
Per minute. Oh yeah. And by the way, this is constant. Yes, you could use it on, and I recommend you look at some of our other videos. You can go to YouTube and TSP channel and so on, and the Motor Age channel, obviously. But the other thing I want you to look at is on a 6 or an 8-cylinder or even a 4-cylinder turbo, you need a minimal of 5/10 of a gallon. If you have that, then you can look at our current and say, you know what? Hey, this pump is a 7 or 8 amp pump, providing all of the humps look even. And some pumps look more spiky like this, some look more rounded. Depends on the manufacturer of the pump.
So what we know right now about the pump on this Jeep, though, is that there's some wear electrically, and we still have a fairly good, consistent amperage. We're reading about 8 amps, we'll call it. Next thing we'll look at, I'm going to look at what's the speed of the pump? How fast is that turning? And how do you detect that? Well, check your pattern, and one of the things I like to talk about in scopes is don't look at the trees, look at the forest. Look for what stands out as the same. You'll find one that gives you an indication of being the identical looking peaks, and then count them off. Here we got 1, 2, 3, 4, 5, 6, 7, 8. That's not uncommon for a fuel pump to have 8 segments.
8 seconds.
On this
Uncommon.
armature.
Yeah.
So I can place the cursors and measure the time. In this case, we're looking at 7.4 milliseconds. If I take 60,000 divided by that,
And let's talk about the 60,000. 60,000 milliseconds in a minute.
Yeah.
Okay, so if you, in case you didn't know that, you take the 1 minute, that's 60,000 milliseconds, 1,000 milliseconds,
Right.
1 second. That's how he's coming up with this
Right, and
calculation.
divide by the 7.4 that we have measured, that'll give you the speed of the pump. Now, of course, the Pico kind of does that for me. This pump's turning about 8,000 RPM. That's a little faster than normal, but does that mean it's bad? Well, I like to look at both at the same time. I have a little higher current, which means the pump's working
A little hard.
against something,
Yeah.
it's working against some resistance. And I have a fast pump speed. So I got to be thinking, this is probably okay. Now, what would be the reverse side of that? If I have high current and low pump speed,
Then we know we got an issue.
now I think now that pump is working hard against something. And
Right.
what's the odds of it working hard against? Got to be a clogged fuel.
Gotta be clogged.
We know they're not being replaced. If that gets full of dirt, it's restricting the flow. It's going to give you a low volume reading at the rail, but my pump current is telling me what's causing that low volume at the rail, not the pump, the restriction in the system.
No doubt.
Now, what's the reverse side of that? If we have low current and a high pump speed, if I have 8,000 RPM but only drawing about 2 amps,
We got a problem.
this is not working against anything, is it?
We have no one home. There's no fuel
There's
that's really
no
pushing.
fuel. There's no fuel being pushed through. Or, what if the check valve is shot? And all that fuel is being dumped right back
there.
in the tank.
Oh, yeah. And these things happen, guys. They happen. So you guys and gals out there that are techs, this is some of the stuff to actually check.
Right. And now let's look at the other parts of this very quickly. Just a second, we'll put it back on the screen. And again, this is what I like about a PC-based scope, because I can do a lot of manipulation with it. Now the green trace, like we said, is the pressure transducer. Oh, sorry about that. I'm going to do that again.
The Pete's blowing it up, and you're going to use the injectors as a reference point.
Right. Now let me go and we'll put some cursors on that pressure.
Watch your language. It's holiday season.
Put one there.
While he's doing that, I've had several people make comments that they've replaced pumps that have current issues after the customers repeatedly run them too low on fuel.
Very common.
Sure.
I used to do, as part of my diagnosis, a quick current check all the time. Most of the time you can get to the fuel pump relay or a fuse. It's not that hard. Some cars, you're real lucky, you can get actually to the fuel pump wiring.
Yeah. And did you ever ask yourself, I mean, if it's constantly being run dry, you see these pumps,
What's
they're
gonna
submerged in gas,
Right.
right? The fuel is actually a lubricant and cooling agent for the pump. So if you run it dry, you're overheating it. That's what causes the damage, just like any other component.
And it's just like if you have a well pump, you live somewhere with a well pump, it's the exact same thing. I had a guy years back tell me he worked for a water well drilling company. He says if you run it dry, you're going to tell by the amperage. So he would check, and he could see, hey, you got low water, you're going to do it.
10 minutes.
Or we got
All right.
a 10-minute warning.
Yeah, so we want to go ahead and move on to this. The injectors, again, are the reference. It's number 1. So that means all the injector events have occurred between these 2 points. This is the pressure transducer signal. I know it's giving me a pressure reading, about 63 psi. Spec on this is 59 plus or minus 5.
5. That's
So
the
the pressure is good. Okay, the fuel pump current was good. The speed was good. So we don't see any issues there. At this point, I don't think there's anything wrong with this fuel pump other than it's showing little age.
Right.
So already I'm thinking, I'm not looking at the fuel system as part of this drivability issue.
And the next thing to confirm that is a long-term fuel trim is not out of whack adding this.
Sure. Now, sometimes you can have maybe just a moderate change in fuel trim and have a drivability issue that
Correct.
could be related to a problem with the individual injector.
That is
What do you
correct.
have to do to do an injector pressure drop? You've got to isolate each injector, you've got to hook up your mechanical gauge, you've got to prime the system, you've got to fire the injector, you've got to record the pressure.
And you got to crank it over so we don't get hydrostatic lock.
Yeah, so you're
That's a
got
lot
to
of
do
work.
this on every single, that's a lot of work. Don't you think that's what we got right here? Pressure drop test already performed.
Yeah.
And I want to point out here, you know, as we're getting close on time, notice I have 3 distinct drops, and then a couple not quite so.
It's almost an identical looking pattern in sections.
Yes, and that's again, we're looking at the forest, not the trees.
Correct.
What do you think makes the difference? Well, I'll answer that real quick for you. All of the lower peaks are 1, 3, and 5. Where they're all on the left bank. Okay, and then the auxiliaries on the other side, 2, 4, and 6 are what's represented here. So I'm seeing uniform drops on one bank, uniform drops on the other bank, and don't really suspect any issues.
And by the way, let's explain those drops. The other side, that bank, 1, 3, and 5, is the fuel getting there at the last minute. The fuel comes in on this side, on 2, 4, and 6. And very common on these are like a multi-spray injector tank that burn up and have an issue, usually from a little bit lack of fuel delivery to that one bank.
Right.
So this is a great setup to actually diagnose something.
Yeah. And if I had any of these that were out of whack, if there was like no drop here, no drop here, now I'm going to look at something specific to that injector.
Injector, right.
And I can use the firing order, and number 1, to identify exactly what injector I want to go digging after. I mean, if I'm dealing with the transverse V6, that's way in the back side.
Right, no doubt. And again, that's where this comes in very, very handy to save you time. Questions, Pierre?
Yes, I have one. Somebody says, I have an issue with a 2006 F350. The wires are burning inside the tank. Any ideas?
Wires burning inside the tank on the fuel pump.
Right.
First thing I would check is obviously for any TSBs, which I'm sure they did. Nothing comes to mind on my end. You probably have, if wires are heating up, some sort of binding condition. Now, has this pump been replaced more than once?
He says,
Or did this just happen one time?
He
You got
doesn't say
wires
that.
burning up
Okay, the
on the
question is
pump.
wires burning up at the pump,
At the
in the
pump.
module.
in the module.
I would take a really hard look at the strainers. If these things are getting restricted, like we said, you put a restriction on the motor of any kind and you make it work
You're
harder,
going to heat it up.
then it's going to heat up. It's going to draw more current than it's supposed to. So that may be a factor.
Yeah. And it's a one-time thing. What does the inside of this tank look like? You know, if this is happening multiple times, you got to be missing something.
Yeah.
But off the top of my head, I don't remember that on Fords. I do remember GM, even with a class action lawsuit, where they had some wire problems. I wrote an article about it years back. Had a pump right in here, with a wire that the insulation would go bare and it would ground out against the little metal frame, with pop fuses and stuff.
Well, guys,
Of course.
I know we're running out of
Yeah.
time, so we got to kind of wind it up.
One last question.
One last question.
One last
From
question.
Joel, he wants to
Second.
know how fuel pump control modules fit into the equation.
Ah.
Joel, I tell you what, write this down, PMEIER at advancedart.com, or hit me up on Facebook, hit me up on LinkedIn's Motor Age Group. Remind me the question, I'll be glad to go in more detail for you on how you're dealing with the fuel pump module and a variable speed.
Yeah, just like the transducer, the skinny of it is, it's going to change current. And
Right.
you'd have to check it at
To
different
test this
speeds.
current pump waveform, you have to manually adjust the speed using your scan tool.
Well, we'd like to thank, obviously, our sponsor. And again, they make this all possible, our friends here at Carter Fuel Delivery Products. Because without them, we couldn't do this. So we appreciate sponsorship of this webcast. We obviously appreciate you guys looking in, guys and gals. Motor Age, if you go on www.motorage.com for text, this guy is everywhere. I don't know how he has time to sleep. If he ain't on Facebook, he's Twittering. I don't know when he has time to do anything else.
Yeah.
But you could always get Pete. For TST, our upcoming events, November 29th is our TST Roundtable. We do a bunch of these. We put them up on YouTube afterwards. It's free to attend. We're going to be hooking a scan tool up to a car. We're going to do something a little different. We should have one of the manufacturers from our BMW scan tool shootout, so maybe you could ask them some questions. December 10th to the 13th, top 10 DTCs. If you're not in Massachusetts on the 10th, or Connecticut on the 11th, and 12th in New Jersey, and here on the 13th of December, well, guess what? We simulcast it, so you can see us on the web. That is a paid for, about a 3.5 hour webcast. At TST, there's our website. We're a non-for-profit group, 501c3, and the sickness, I could barely speak. I want to thank you and your family. Happy Thanksgiving to both of you. And of course, Pete Meier here from Motor Age. It's always a blast doing a webcast with him.
Yep, and we'll be back here in February. Thanks so much for coming out tonight.
Have a good night. Thanks again.